Hello everybody, welcome back. Now this part is going to concern with domain, codomain and range. Basically this is very important as far as functions is concerned, but we will be starting with the basics in the relations also so that we get to familiar with the terms, and this is the most important topics when it comes to functions. Lot of questions are straightforward from this, although we are going to discuss what these are, but we will actually learn how to improvise on it in the functions, that is the other set of videos which you might be getting. So for this we need to learn basics. Let's start with the parts. So let's start with this thing now, domain, codomain and range. Basically it's a very important topic for functions, but not for relations as such, but we need to understand like what actually these terms means, as these are going to help in the functions, okay? Although they will be taught in that also, but just for the sake that you people are familiar with these terms before you move on to the functions, this is very clear. This should be made very clear, and this is again one of the most important topics for functions. Like when you're dealing with the functions, this is the question asking area in the JEE Advanced regarding the domain, codomain. Let us understand what does these terms actually mean in a relation. So if I am defining a relation from A to B, obviously you can see that this is going set A and set B is related to, now as I mentioned, that relation is a rule. So by that rule we are connecting some elements. So in that, now if I am talking about relation, so that will be basically R will be a subset of A cross B, that I have already talked about, that Cartesian product. So domain will basically be, in that relation, the set of all the elements which are occurring as first position of the ordered pair. Like suppose in this set I am having 4 ordered pairs. So the set of all these first elements, this is basically my domain for that relation. Okay, so it should be very clear that the domain is whatever is coming in the relation. This has nothing to do with the original set, but you can say that domain will be the subset of your original set A. Okay, that's the only relation it will have. For some B belong to B, domain will be the set of all the first elements of ordered pair which belong to R. So talking about the range, now range is all the second element, like which, now suppose you are applying a rule, okay, so it means you are relating an element of this to the element of set B. Now domain is basically this element which is being connected, and the range is a set of all the elements which are given, like if I am saying A is equal to B plus 1 and my ordered pair is A comma B. So if I am keeping A as 2, so 2 will be related to 1. So 1 is basically all the sets of this thing will form range. And the codomain, so read here that the range will be set of second elements which are ordered pair which are belonging to R. Again depends on the definition that what from where the A and B all are coming. And domain is, as I mentioned, subset of A, and again it can be a set itself also, like all the elements of that set are being part of relation, as we have seen in the case of different relations, that depends on the definition that A cross B itself can be the relation. It's a relation where all elements are being connected. So in that case A will be the domain, B will be the range. Okay. Now codomain is basically the set possible values from which range can come, that is the set B itself. Okay. So if you look at the broader diagram, so domain is whatever is connected here and becoming as a part of relation now. Now let me draw a picture of this thing. Now with elements it will be more easily understandable. Now suppose if I am writing this one, so my relation, now this is again the way how we represent relations when we are connecting the two sets, pictorial way of representing the sets individually, and then arrow diagrams. These are basically called arrow diagrams, which most of you might be knowing. If you are not, then you can just learn it right now. But arrow diagram means you are relating one element to the other by using the arrows. Like 1 is connected to A through this arrow, 2 is connected to A. So the relation will be 1 comma A, 2 comma A. Now here you see that the domain is 1 comma 2. This is domain and range is A. Whereas codomain will be the all set possible values of range, basically, which could have come, and there is no as such term defined for the set A. Okay, you will get to know that why it's not defined when you will be going through the function part, function series, and in that you will be taught that why that domain is always the set A, then only it will become a function. So that will be the basically condition of the relation to become function, which you will study in the other part, but not the other part, but the other video. So you have to be, now you must be knowing that okay, domain is something which I am picking from set A, which performs a part of relation, and that is always the first element of the ordered pair. Combination of that becomes domain, whereas the second element becomes a part of range, and the set from which the range has come, that becomes a codomain. A perfect way to see representation through the sets. Let us practice some questions so that we can make the concept more clear. So A is this set, R with the relation is square of NA. Okay, which of the following is false? Now when I am talking about R with the relation, so it means R is having this thing, and relation in A means that both the elements, both the sets, they are A and A, that you are relating A to itself. Now the condition, the rule which makes this Cartesian product a relation will be, rule we will be mentioning that obviously A will belong to A, B will also belong to A, but this would have been the Cartesian product, but this is not what we want. We want this A is a square, the first element is square of second one, that is B. So that is A is B square. That's how we would like. So we'll see that from 1 to 45 I am relating, okay. So my elements will look like B square comma B, where B belongs to A. Now B, if I take B as 1, I can have square as 1 comma 1. If I take B2, it will be 4 up to. Now if I take 7, this will be okay, but this is not present. So this cannot be, A cannot be part of A, like A has to be, B square also has to be part of A, right? So that is why we cannot pick this. So it will go up to this one only, which is the right there in the option A. Now domain of R, now just observe the relation, domain will be the first set of first element 1, 4, 9, 16, that is all the perfect squares which are part of the domain. Range again is the second 1, 2, 3, 4, 5, 6. So none of them is the false one because everything is true here. So again you need to be very careful that domain, range, and if I would have asked codomain, the codomain would have been the set A itself. Okay, so make sure that you're not making any mistake in that, and always in such questions there might be some element given wrong. So observe each, don't go on okay 149 is given. Suppose somebody would have cleverly given here 24, then this would have been the wrong option. So check each element, because while we are seeing a pattern, we are assuming in mind that all the elements are following that pattern. Okay, so you should be very, very careful about that. And this was perfect to understand domain, codomain, okay, and the mistake which most of the time happens, I have already mentioned about that. Moving on to the next question. Let R be the relation in N defined by, now this is the definition basically, that your x is going to be 8 minus 2y, or you can take y as 8 minus x by 2, it's your choice, but I prefer this way because then we don't have any division problem, like we can take y independently. The range of R is, now R is a relation in N. Now N stands for basically natural numbers, set of natural numbers. So if I am saying relation in natural numbers means from natural numbers to natural numbers. So this will be set A and set B. So the range of R is, now you have to list down the elements. Now first, if I am starting with y, so y if I take 1, what will be my x? X will be 6. If I take y as 2, 4. Y as 3, x will be 2. Don't take y as 4 because 0 is not a natural number. So these will be the ordered pairs basically. And if you want to find the range will be the combination of second elements. Now don't, what happens most of the time, if you are substituting 1 here, you write it as 1, 6. Don't do that because the pair is x, y, okay. So you have to be very, very careful about that, this one is not gonna work like that. You have to make sure that if you're substituting y, put it at the accurate value, like where it should be, okay. Do not think that what you are putting in or getting out. So this will be the range of the, now codomain, if I would have asked, codomain would have been then the set of natural numbers itself, from which where we are picking up the values which can be fitted into the range part. Moving on to the next question. The relation R is defined in A by A related to B if this is true. Which of the following is, again, the word false is very, very important, and you have to be very careful while you are studying the things, and you should be very, very careful while reading the question. A is the set. Now this is defined, a square minus b square. The mod of a square, this thing is less than 5. So you can just start picking up the values basically. If I take a as 1, now 1 square minus 2 square will be, mod will be 3, right? So it will be less than 5. So that is acceptable. 1 comma 1 is also acceptable, that is 0. There is no restriction, right? It's not said that b cannot take the same value, so we can take the b as same. So 1, 1, 2, 2, 3, 3, these 3 are going to come, okay, obviously. Then if 1, 2 is there, obviously 2, 1 will be there. Why? Because whether I take this one or whether I take b square minus a square, both will be behaving in a same way. So that is how the things you can say that it will be. You can go by symmetric nature basically. 2, 3 will be there, 3, 2 will be there. So you can check that 1, 3 is the only pair which won't be there because that will be, so vice versa it won't be taken. So very easily understandable this one. Now R inverse. Now inverse right now we have not studied, but since it's there, so inverse basically means you invert the ordered pair. Like if it was a comma b, inverse basically means b comma a. So once you have got this one, if you invert it, if you are getting it same, now see that due to symmetry, like if you are getting 2, 1, 1, 2 is also there. So you can see yourself that the opposite one is already present. It means R inverse will be. So what we can conclude from here, that if a comma b and b comma a, they are both present in the given set or given relation, then always this will be true. Okay. Domain, as you see, 1, 2, 3. There is no other element present, so domain will be. Now range clearly is wrong. Okay. Range clearly 5 was never an option, so this was the straightforward choice. If there would have been something different or multiple choice kind of thing, then you must have looked it for twice. So that's how you are going to decide all the domain, codomain, and these type of questions are always going to appear. Like these are very basic things, but when you will be going for functions, so in that you are going to really the rules are going to be complex. Like this was an easy rule. So if we apply some conditions on this rule, the relation becomes function. That you will study in that, and that is again the most important topic I would say to start with, and you must seeing after sets and relations, go for that immediately, because that is where you will actually apply these things which you have learned here, and it will be very, very helpful. And this topic especially was not as useful in the relations, but it will be useful once you will start that, and you will then remember, okay, we have already done that, so now it's easier to understand domain, codomain and all. I have the concept of domain, codomain and range. They are pretty much clear, and you people might be now understanding that range as a subset of codomain, and there's nothing so much difficult about the domain. All you need to think is that what you are giving in, that is domain, what you are getting it is codomain or range, and the possible values of range from which the values which it can take, that forms codomain. Stay tuned for the coming parts.